Hi everyone and welcome to a new video. Today we have Dhruv with us. Dhruv is going to help me and Shekk understand what is a validator, how can you run a validator on Solana right now, what are the challenges that come over here. He's been running one successfully for a few months or I don't know, a few years now. So he's understood the ins and outs of how do you run a validator on Solana. And we'll try to do a very simple one-on-one and also try to run a validator on testnet in real time. With that, Dhruv, can you introduce yourself a little bit and tell us what you do? And then take us through the validator.
Hey guys, I'm Dhruv. I run like Solana Validator. It's called ice staking. I also run like white label validators for a few people, and I help few people with some RPC and engineering stuff around Solana as well. So yeah, that's majorly about me.
Cool. Can you take us through what a validator is? What does the internals look like? How does the Solana blockchain look like? What does a validator do?
Yeah. So validator in general, the code base is same. So we have like three clients assume. So we have like Agave.
Sorry, one small call out. A blockchain has a bunch of these validators. It's basically nodes that you run on your house, very big mining machines that people have that are constantly doing some consensus. That's how people make money by running mines. You might have seen one at your friend's place. So Dhruv runs a bunch of these, and he's taking us through. Let's say it's the Solana blockchain you're going through. What exactly a validator does there?
Yeah. So we have like few validators on Solana, few different clients of the validator. So first is the Agave client that is like maintained by Anza team. Another is Jito, which is Agave's fork, but they've added few stuff around MEV and all. And the third is Fire Dancer, that is Fire Dancer or Frank Dancer, which is still in like work. It's another client. Also, there's another client by Syndiga. It's called Zig. Uh, Sig. Yeah, it's called Sig. And yeah, so these are the like, oh, also we have Mithril. But Mithril, everyone is like focusing on a different section. So uh, yeah, but basically these are all clients. Few of them are under development, few of them are running in production. But basically we'll majorly talk about Agave because it's much easier for everyone to understand because each of these clients have different functionalities that differ them or different way they have built in. So yeah, specifically for Agave. So Agave has like two major components. First is so you can run the whole code in two different ways. First is like a voting mode. Another is the non-voting mode. And majorly, these two modes are used. Like these two modes are the only thing that exist. And yeah, so voting mode is like voting mode gives you consensus. So whenever you want a validator to participate in consensus of the blockchain, then you use this mode. This mode basically whatever key pairs you define, we'll talk further in this about that in the video. But the key pairs you define will they'll do transaction sign on votes and vote on the consensus of the chain. Then you can run it in like non-voting mode. A lot of people do this because that's the way to get data from the chain. So you have RPCs and all. RPCs are non-voting validators. You can and people use few for like as a like a state verification and all. So you run it in archival mode that is basically keeping the whole history of the chain. So in Solana, you can like either keep like a short amount of history last and say that I have like maintaining my history for this period of time. That is much easier to run. Or you can maintain a full archival size history that's like some petabytes or yeah, some crazy numbers there. So yeah, these two are the major versions. And
And if you want to actually take part in consensus, which means you actually want to mine some Solana and make money, then you have to run a voting node.
yeah, then you have to run this voting mode. That is basically you participate in consensus, you vote on block, and you get block reward. Or if you're running a Jito client that is specific to MEV, then you're making some MEV. Like you can add some commission in MEV, or you have like inflation rewards and all. So yeah, immediately.
Got it. So when the Solana blockchain started, you're telling me a bunch of people all around the world started these these nodes in voting
Yeah.
mode. And whenever you do a transaction, whenever I send someone Solana, I hit one of these voting nodes and tell them, hey, I want to send one Solana to a friend.
Yeah. So basically, so whatever you use as the non-voting RPC,
Right.
this RPC forwards this to the voting node.
Mhm.
Let's change this to voting node. So it's
Yeah.
voting node and voting node. Yeah. So basically, this your RPC just forwards your transaction to the voting node,
Got it.
and there are few other parts that you have to be leader and all. So the transaction only leader build blocks and all. But yeah, that's specific to Solana.
Got it. So on Solana, if let's say there are 1,000 validators right now, I send a request to an RPC node that I rented, let's say from Alchemy or Helios. It
Yeah.
forwards it to one voting node, and until that voting node becomes the leader,
No.
my
So it forwards it to the leader, and leader
okay,
builds a block. So yeah,
got it. But does the leader change very often in Solana?
yeah, it changes every. There's like a batch of 400 milliseconds. So that's called a slot. So
Mhm.
every four slot a leader changes. So you have like four consecutive slots of being leader.
Got it. So the non-voting node is aware of the current leader and forwards all
Yeah,
the
yeah,
requests there.
yeah. They
Yeah,
maintain
so
a
this leader schedule is like published prior for every epoch,
Oh,
has a predetermined leader schedule. That's how majority of the proof of stake uh, blockchains, they work on these epochal stuff, right? So you know who your own participating validators are for this particular epoch, and you also know what their stake distribution is. So based on the stake distribution, they create like a, a randomized schedule of at any given time who is going to be the current leader. Because if you don't have that schedule predetermined, you are going to end up wasting a lot of time gossiping across the entire network on who the current leader is.
that makes a lot of sense. And few questions then. It's predetermined for how long? For the next 20 hours, for the next 2 hours,
For the epoch.
for the epoch.
So yeah. So for example, when you stake sold, maybe the Dhruv can chime in here. When you stake uh, to a validator,
Yeah,
the stake is frozen for a given epoch.
right.
So this is the reason why when you want to withdraw a stake, you
Yeah.
can only do it after the epoch boundary has crossed. Because for that given epoch, the leader schedule is predetermined. That means that the stake distribution is also predetermined.
Got it. That makes a lot of sense. And one epoch has how many slots?
one epoch has like 2000 200K it's basically
Roughly.
200K ish
Yeah.
slots roughly. Oh, sorry, 400K. That 200K is in a day. So a slot is like epoch is 2 days and few hours. So it has roughly like 400K
Yeah.
if I'm
So
correct. Yeah.
yeah. So for every 400 milliseconds you have a slot. So that means that every 86,400 into 2.5 per day. So that's around 180 or 190K per day. So epoch with 400 millisecond typically lasts like 2 to 2.5 days. So then it's like close to, I think, yeah, if the math is right, it's probably around like 500K slots
Epoch.
per epoch.
Got it.
It's roughly around.
What happens if a validator goes down in the middle of an epoch? There was already, the leader at a scheduled time.
Yeah, so
So
that's the you skip. You want
yeah,
to talk about?
you skip that slot basically. So I I I was supposed to vote. I didn't vote. So that slot gets skipped.
Also, transactions don't land for that specific period.
Yeah, yeah. So that usually happens because there's like two parts to it. You have slot and you have block. So it's like every block will be in a slot, but it's not vice versa. So every slot doesn't guarantee you a block that a
Got
block will
it.
be produced. But yeah,
So it can be an empty slot if the validator
yeah,
is
yeah,
down.
yeah. The validator went down or something like that happens.
Got it. And a single slot can have multiple blocks or just a single block?
A single block.
Single block. All right. A block is nothing but a bunch of transactions that people have signed, I would assume.
Yeah, yeah.
Great. All right. That's beautiful. Sheikh, do you want to add something? I understand this very well now.
Yeah, I think this is very clear. So, and also compared to other blockchains, one thing is that, for example, between these, even you might have noticed when you construct a Solana transaction, you specifically might give a block hash, right? So that is specifically to say that, like, until what time this transaction is valid for. After that, you can't, even if you want to, you can't execute that signed transaction because it has expired. So typically in a block you will have these interleaved transactions which need not necessarily be related to each other.
So if I want to start a voting node today, I need to get, I would assume, a very heavy machine. But is that all I need? If I get a very heavy machine and start running the Solana client, let's say the Agave client over there, am I now making Solana and participating in consensus?
Will you need like voting costs for that? So since consensus is on chain, you have to vote, and each vote is a transaction in itself. So that basically will cost you Sol. So roughly in a epoch, you'll need like 2 Sol. That's a rough estimate, but roughly you need like 2.1 Sol to 2 Sol, somewhere in between. But
Got
yeah,
it. So on my voting node, I just need, let's say if I want to run it for a month, and considering an epoch is 2 days, I need like 30.
30 Sol, yeah, 30, around 30 Sol.
Got it. And now I can participate in consensus.
Yeah.
Um, how much will I make back on the 30 soul if I'm participating in consensus in a month?
Will depends on like how much stake you have. But let's say you just cross. So I think roughly you need like 50K Sol stake to become profitable.
Okay.
That depends on Sol price, how much block rewards you're getting. So recently, like last month, the block reward were very high. This month it's like average. So that's the thing.
Got it. So you mentioned a few words here. You have to put in a stake and you get a block reward. So could you elaborate on what a stake is and how do I
Yeah. So
go in?
stake is basically whoever people are trusting you with their soul, and they're saying that they'll just take their soul with my node. It's not like they're giving me the soul. It's like they're saying that uh, use my soul to validate the transaction, and that basically guarantees a node in general, because the more stake you have, the more better you are in general. So that is one
Okay,
part.
so the leader schedule algorithm is designed in such a way that it is stake weighted, right? So it creates a leader schedule. So the higher the number of stake you have, the probability that you will be a leader at any given point in time is higher. So that means that, for example, in an epoch, let's say there are 500K slots and you have a validator set of say 3,000, right? So naturally, you want to construct the schedule in such that the one with the highest amount of stake is the leader for as many slots as possible. This doesn't mean that the one with the lowest stake won't be a leader, right? They will be a leader too. It's just that the incentive to attract stake is that you actually can become a slot leader at any given point in time.
Got it. So if today I start a voting node and put 30 soul in it, there'll be barely any transactions or any blocks that I can propose. I will not be the leader very often, but if I can put a lot of soul in here as stake, which could be my personal soul, or I can ask a few people to stake with me. Let's say I'm able to gather 100K soul. That's whatever 2.5 mil. I don't know. Math could be wrong, but I need
Yeah,
that
25,
25
25
mil.
days.
All right, 25 mil. Then I need to, then since I have so much of Solana staked, I'll be the leader more often. And that's how every time I'm a leader, I'm making some fees. So, I'm becoming profitable or making Solana. So it's not as easy as just starting a node. You need to gather a lot of Solana from people and keep it in your node while your validator is running. And why does that happen? Why do I need to stake? Why can't I just run something like, Bitcoin or proof of work or, without any staking?
So the way when Bitcoin started, right? What Bitcoin fundamentally showed to the world was that, hey, you have two functions or one function executing in two different places, right? So Bitcoin gave the guarantee that if I were to execute this function with these set of inputs, it will always produce the same output. So how do you ensure that, right? For example, if I do a function, say credit Dhruv by this is my input of 5 BTC. I want to credit Dhruv by 5 BTC, right? So if you were to execute this specific function, that should result in an output where my balance goes to 0 BTC and Dhruv's balance goes by plus 5 BTC. So I remember that anyone can run in this completely Byzantine system. Anyone can be executing this code. So now how do you generate a guarantee that this piece of code was executed correctly? And for this same set of input, this is the output it is going to produce, right? One way to do that is that, hey, you know what? This is the function that everyone is going to run. I am going to verify by re-executing the same thing with the same set of inputs. If all of us get the same output, it's great, right? Like we can vote. Like that's how your typical consensus works. But in a Byzantine environment, what can happen is that I can, without executing, can say that, hey, you know what? Oh, cool! I did the work, and this is the output. Or while I need not even have done that work, right? So what proof of work, what blockchains did was create this proof of work algorithm where you have to compute, like the only way you would arrive at, everyone would arrive at the same answer is if had done some work, and that work involves solving a very, very computationally intensive problem. The only way you would arrive at that answer is if you actually solved it, and that's why it was proof of work. As you can imagine, this is not only are you replicating the same set of computation across every node that exists, you're also replicating very expensive computation, right? So this doesn't really scale, and it ends up creating like a lot of what do you say, wasted compute, and it ends up consuming a lot of electricity. So that's why people started working on, hey, you know what, proof of work doesn't scale, and you want to build like very, very high performance systems. Then came proof of stake. Right. So with proof of stake, hey, you know what? Instead of anyone, it starts with the idea that anyone who has the economic incentive in the network is not incentivized to lie about the execution of a function or whatever happened there. Because if they do, and they do get caught, they're going to have severe economic consequences, that they're going to lose their money, right? Like you will get slashed, so on and so forth. So that's why proof of stake came about as a replacement for proof of work.
Right. So, okay. So if I understand this correctly, Bitcoin did not have to stake anything because Bitcoin did not use proof of stake. It used proof of work. Everyone had to solve a problem to prove that they had actually done some work, and hence they can propose the block. There was no concept of a leader selection. Anyone could be the leader as long as they solved the puzzle. But
yeah, the first one, like whoever like raises their hand saying, hey, I found the answer, right?
Right. That makes sense. And this was computationally very expensive, harmful for the environment, and hence proof of stake came. And it simply says, it doesn't matter how big of a machine you have now, you don't have to solve a puzzle anymore. Just stake some Ethereum, or in this case, Solana, and we will trust you. But if you do something bad, we will slash your Solana. That is why Dhruv said you have to put 50k SOL or 100k SOL. The more SOL you put, the more the probability of you becoming the leader. Why? Because if you are the leader more times and you try to cheat the system more times, you have more stake that can be slashed.
Yeah. That's pretty much that's pretty much the idea behind proof of stake, right? So, but then proof of stake, there's uh, proof of stake kind of make this much more an economic and a mechanism design problem. Now, that doesn't take away from the fact that people can lie about so many different things, right? You could still lie about execution. Someone can acquire like a very large bag and still lie about execution. So lot of the developments in the proof of stake world has been about making things obvious as to what you cannot lie about. For example, in Solana, because you have proof of history, you cannot, everyone would be able to compute the order of the events that happen because you have the POH hash, right? So the different proof of stake chains do different things, but the interesting point here is that, for example, when you're running the validator, you want to ensure that you attract enough stake so that one, you're incentivized to be part of the network, and as you're incentivized to be part of the network, will you're also incentivized to be a good player, good faith actor in the network, right?
Makes sense. That makes a lot of sense. So now I have a voting node and I've put some Solana in there, staked some Solana of myself or from my friends. Um, what's the next step? What kind of accounts do I have to create here?
So majorly you'll need like three key pairs and one account. So one key pair will convert to account. You can follow the official docs for this. So Anja has the like good docs for this. Validator. So basically, you need three key pairs. First is your validator key pair or identity key pair. You zoom in. The other is the vote account. This will key pair, and this will later convert to a proper like PDA. And third is the authorized withdraw. This can be your ledger, squads, a multisig, or anything. This is to remove funds or do any kind of like changes to this account. And you just there's a simple command for this. Just create vote account, and you just pass in all the three one after the other, and yeah, that's what you have to do.
Got it. So is there some validator program on the Solana blockchain where you create this PDA?
Yeah, yeah. So there's a vote. Yeah, there's a program vote account. Yeah, but like basically you just create a PDF. I think there's a program called voting 111 or something like that is the thing called.
Got it. Makes sense. Okay. And this defines the identity of a validator. If I
Yeah,
have these key pairs, if I use the same key pairs on three different machines, I'm still the same single validator.
yeah. But you cannot vote because your vote will conflict.
Right.
So
Right.
yeah,
Makes sense. So if I want to run 5 validators, I will need 5 of these key
please.
pairs.
Yeah.
Got it. Makes sense. Yeah. Cool. So you create 3 accounts, and then what's the next step?
Then you just have to like get a good server. So you need like Latitude and all for that. You can follow.
So Dhruv, can you show us how hard is it to set up a validator? Can you show us what kind of nodes we should pick up, what cloud providers we should use? Feel free to share your screen.
Can you guys see my screen? Yeah. So, well, there are like a lot of providers, a few famous ones. So you can refer to this list. This is made by a friend, hcl.org. This basically is specific to Solana validator, shows like bunch of configuration, so CPU speed, etc. In Solana specifically, you need a higher single core performance because of the how it's configured and how POH runs. And this basically shows all the like the different CPUs you can run with their base clock. You basically have to run it in like performance mode to like get good power out of it. So just that, and mostly you the architecture is AMD specific, so it's much easier to run it on Apex or Threadrippers. So yeah, these are the few ones. And in terms of providers, you can use Latitude. These are only few of the providers though. So Latitude, Edgewana, TerraSwitch, and all these have like good servers, so you can use any of them. I specifically use like Edgewana and few other like specific ones that are not listed here, majorly because those guys don't have a lot of stake. And there are a lot of different things like city concentration, provider concentration. So in a data center, how much concentration a validator has, like a specific node has, that differs. So that also gets tracked. So I can show you something. So this is for my validator. So it also checks that what is my ASN concentration, that is basically from my providers. What is my, so I'm running, this is my backup node running in Madrid. So I have very low. So this improves my like general score in general, and stakeways perform score is like considered good in Solana. So yeah.
Why is this code important, or what role does it
As
play
such,
if you?
not important to say. It doesn't help you get stake in any form. It's just a general tracker that how much your node performance has improved over time. I can show you something else as well. So Shinobi has this performance pool, that is they actively track all the validators' performance and all. And if and you see like all the metrics and all that they are tracking. So for me also, when I switch hardware, you can see like a difference. So this is like voting latency. This means how much vote I'm doing in a epoch. So I'm doing like 99.3% of the time I'm voting, my node is voting. So you see like there's an increase from 97 to 9. This is when I change hardware. And usually when you move to a better CPU or do like different stuff, you, yeah. And yeah, this is the same thing. Average vote latency. This is basically how fast you're voting, and when are you like like when you vote, how fast it lands, and all. That's why city concentration is important, because how far are you from the center will change this value. And yeah, that is. And there are a few other metrics like compute unit. So this is how much compute you are packing in a block, consensus voting, and how much transactions you're including, getting included, and yeah. So this is first, and maybe you can just jump into the like the node and how to set up it, the basic stuff. So I already got a node. Wait, let me show you the config. So I took a like a rented node from Latitude. So for Solana specifically, you need uh, bigger bare metal nodes. So this is a 380. Yeah, if you see, this is like 384 GB RAM. This is like overkill. I was not able to find a small node than this. And you need like decent side NVMEs, because you have accounts and ledger on NVMe, and that basically needs to update every slot or every state change for accounts and all. So, and you need a higher clock speed. So that's why this processor. And yeah.
How much does this one cost per month?
This is some $800. So I did a hourly, but so it differs. If you pay for a longer term, then it becomes cheaper for you. So yeah, this one is some $800 a month, but you can get a like similar machine for like 700-ish. But yeah, that's the rough range for this spec machine. But yeah, basically I've SSH into the machine. I can show you the disk config. So I have those two disks, right? These two. I've configured them. I've like configured them, yeah, here. So these two are configured. Both first is for ledger and other is for snapshot and accounts. And just jump in as well. So this is this directory is for accounts and snapshot. Snapshot is basically just a snapshot of the chain, and that allows you to load faster in general. Accounts is the state. So it has few stuff. This is not like or right now on. If you see, I'm not running anything. It's just like 1 GB use. So yeah, basically you just have these directories set up. I have like both of them mounted in a different place, because in general, disk usage is important. You have to track and all. I can show you a Grafana dashboard as well for the same. 1 sec, let me pull there. So this is one of the community dashboards where I'm posting my server stats. And you can see so bunch of servers has majorly IO awaits. That's where your IO time is, input output for the disk. And these spikes occur when you have like a replay stage going on and you get stuck, so you have to replay a lot. And that's why so disk usage is majorly important, because you have to rewrite stuff, and that's why two separate disks, so there's no like lag in terms of performance there. And yeah, majorly most of the setup, yeah, also I've created a user, and this user has a few stuff set up. So First is like three key pairs I've set up. So the V2 one is the voting account, and this is on testnet, so you can just search it in the Explorer. So I've set up it, and you can see who can authorize the vote. So in a validator, you have two major pairs. One is the vote account that keeps track of all your votes and all. Second is the pair that pays the fees and does the vote. So it shows that IE6, this is the pair, and if you see this is another key pair. And these are key pairs here. Usually you should not keep like this. This is just for the demo. Usually you have something like Hashcorp Vault or any kind of vault service that allows you to do this. And another withdrawal pair is here. And then the main file, there's some system config as well that I did. So I can just show you that as well. It's basically what I usually do. So I wrote a guide to just handle this. So this I've already done this, but you have to just change few network config, basic general TCP stuff, and you have to set your CPU and remove all the like the move everything to performance mode. So it's basically overclocking, and yeah, that's. And you also have to do some like file specific stuff. So there's like file limit and all. You can do either one of them. Yeah, there's like few extra stuff, but we can skip that. Yeah, and so I have this startup script. Um, this basically what it does is specifies what I want to do. So I specify my identity and all here. Tell that only known RPC, that is another few flags. I specify all the directories, RPC that I want to run which port. Ledger size is just so I don't like bloat my ledger. I don't want to run archival nodes. I can limit my ledger size to keep like last few epochs and all. Some binding stuffs, few entry points. So this entry points are used in Gossip when I want to enter Gossip and all. And some known validators. This is for basically downloading snapshot, download like matching up any versioning and all. There is expected shared version, and this is basically how do you define a networks version? I don't have a technical definition for it, but the instance of Solana I'm running, which instant I want to enter, so this shared version specifies for that. So whenever Genesis change happens, this version also gets updated. There might be a better technical definition than this, but yeah. Few other stuff like I was testing this central scheduler, and there's another scheduler as well. So I was just playing around. So that's why this is here. And yeah, this is the main config file. There's also to keep the whole validator running, you have to specify a systemd config as well. I'll just show that as well. So in this, basically some like local stuff, and I'm just telling it to um, run my validator with the startup script that I showed about. And yeah. And usually you don't run your validator in like the root user, you run it in a sole, like a different user. Usually people call it sole. Reason being you don't, if someone is accessing your ports and all, so it's better to not have your root user run anything. And the sole user doesn't have sudo access, so that prevents a lot of like security issues in general to the machine. Also, I opened few ports. So I have like SSH port open, and these TCP ports are for TCP UDP ports are for Gossip. So I can specify like port range, and the Gossip will operate in this port range. I don't have RPC port open. Usually no one does. Everyone uses Nginx or something like that to proxy the parser. Because if you open the port, then it's super hard to for the node to or near to impossible for a node to catch up when you have that specific port service running and with open port. Yeah, and I guess we can start. There's nothing specifically missing from this. So to start, you just have to like start the service file. So when you go to again log back, so I used to use sudo, so that's why it was like the my root user, and I came back to sul. And if I do saf on the log file, so you can see it's starting up, and it's basically trying to see which RPC or validators are available in the region. So it found one RPC, and with that one RPC, it pulled up the whole list of like the people that are in gossip, and slowly it will start to download snapshot and we'll just start up. So yeah, that's pretty much it. What you have to do, minus all the security stuff that I passed over. But yeah,
Got it. And you said you have like a GitHub repository where people can look at and run the
yeah,
same codes.
yeah. It's hosted over iStaking slash Validator Jumpstart. So it covers most of the paths. I skipped like bunch of basic stuff. So like it doesn't tell you how to create account and all, vote account and all. So but it has all the configuration. There's like all the system tuning that I do. This is specific to what I do. Bunch of people do other stuff. And yeah, I have like a custom script and all because the client that I showed you running here, it's called Agave. Oh, also, we found a snapshot and it's trying to download it. Uh, yeah, oh, we missed it. But yeah, basically this client is Agave, and this is like the primary client. There's another client by Jito that is forked off Agave and has some MEV stuff involved. So on Minute I run that, and my like the this whole setup script is for that only. So yeah, that's majorly the difference. And there's like I've done few shortcuts as well. So some aliases to help just whatever I did there. It's the same thing. And yep, so there's a hot swap guide. So you can hot swap between like two validators. So you don't have downtime. If you see my like most of the validators that can afford like two nodes, they usually don't have downtime. So if you see, I have like 100% uptime. That's because whenever I want to switch version, I can just like hot swap to the old machine. And yeah, the guide basically has few other stuff, log rotate, so your log file can get super big. You just want to like keep this going, so small version going. So that's for that. So it keeps like a 7-day track. Yeah, and basically few other stuff. So theme command that I run to initialize. Yeah, few monitoring solutions. So the Grafana dashboard I showed you is by Soul Economy, and these guys are good. So like there are a few others. So the official Solana Labs also has a uh, Grafana that like you have to report your metrics to, and if you watch, so you have like monitoring system, pager calls, etc., etc. Some general like issues that I've faced over time. So not to run it, root user, sudo privileges avoid, etc. SSH issue. Backup logs just in case, and you, a whole part of creating a snapshot is missing from this. So whenever a cluster stops, you have to create a snapshot and roll back or adjust your state. So that part is missing, but that is usually not a bit difficult for a business, so that's why it's not in this. But that rarely happens. uh, yeah, so that's about it.
Got it. So, and you're saying you're running this on testnet?
Yeah, this one is on testnet.
Where did
I
you
have like
specify that?
sorry.
Where did you specify that?
Oh, testnet. So if you see the startup script that I mentioned,
Mhm.
so there's two things in this that specifies. So first is this entry points. If you see, these are testnet entry points.
Mhm.
So that's why plus this shared version as well. So this is for testnet. So
Got it.
these two combine plus the other nodes. These extra nodes are on testnet as well.
Got it.
So yeah,
Makes
and I
sense.
made the voting account on testnet as well. So these three four stuff.
Got it. And you mentioned there are two accounts, the vote account and the the
Identity
identity.
account. Yeah.
Um, ठीक है. And with
Identity is just a normal key pair. Vote is account.
identity is a normal key pair, and vote account
Yeah,
is a proper account
account.
on.
Solana, yeah.
Got it. So like a PDA.
Yeah, it's a PDA.
I was asking when you say it's an account, what do you mean? The vote account?
It's a PDA specifically.
PDA.
Yeah.
Got it.
People yeah.
Cool. So if I want to start one today, I'll get a node from Latitude with similar configurations to yours. You created two separate mounts, one for storing validator, one for storing the snapshots, and the other was for called extras. What did that one do?
So it was so basically the first one is for ledger. Oh, sorry, this one is for ledger. So keeps the whole state and etc. etc. And this extra is just so I don't have to like make two directories. Inside the extra is just accounts and a snapshot. So it's the same thing.
Got it.
It's like two different things. I didn't have like three desks on this, so I had to move a
These
bit different.
devices are also infrequently accessed, right? For
Yeah.
example, the read pattern, the read and write pattern on extras is very different from the one on Ledger. Ledger probably a lot more frequent compared to extras, so that's where you were showing the IO graph. In order to prevent such bursts, you have kind of like put them in two different devices so that you have predictable, uh, have much more predictable IOs on both of these, right? So one question I had, which is few things you mentioned, right? One, it's interesting that you're running, for anyone watching this, it's interesting that why even go towards a bare metal. These things, like almost everyone knows AWS, GCP, DigitalOcean, but things like there are a lot of new names here, right? Like TerraSwitch or Edgewana. Th- these are all, or even Latitude for that matter. These are all very, very new names, infrastructure name for a typical developer. So why is it that running a Solana node needs these type of machines, or what is it that they provide
Majorly,
that is not typically available in AWS or GCP?
yeah. So majorly, all these AWS and all offer like virtual cores and plus the bandwidth cost. So if you have like virtual cores, you cannot pull that much performance out of them. Rather than what you can do on bare metal, you can run on overclock mode. You can just like system fine tune the system. So the config that I showed earlier, that is what I do. Like bunch of people do differently. So that like very low level configuration is one thing. Other is the bandwidth cost. So minimum you need like 100 TB bandwidth in a month, and that is and and bunch of like GCP and EC2 AWS like services charge on bandwidth as well. So
Yep.
that is not like scalable on in terms of how much money you're burning on that just specific server, where it's much cheaper to get like put $800, $1,000 here, and you get like 1 TB of 100 TB of bandwidth, plus all you can custom fine tune the server. And people are also very like scared of what who is accessing your data. So a
Mm.
bunch of people they use IPMI, that is basically allows you to gives you a nice UI to like load Ubuntu on a load any Linux on a like a system. So people do that as well, and it's basically just that.
Got it. Makes sense. Okay. So I create these, mount these directories. I create a new sole user, and I go through your startup guide, bunch of other configurations that you made, and you ran that one command which you mentioned was the. I'm assuming that's the ANSA client, um, and you
Yeah,
were running. You
yeah,
started running, and it's now
yeah,
catching up.
yeah. Let me pull up the monitoring. So we downloaded the snapshot. So let's see what's this sheet. Okay.
So snapshot is the current state of the blockchain, all accounts, all balances, everything.
Well, yeah, it's like it fetches the last bit of snapshot. It's resetting the viewage thread. It seems fine. So we caught up as well. So we are,
Was it this quick because we're on testnet?
yeah, yeah. Oh no, we are very far behind. We have to, yeah, we have to restart once more to get back on track. We are too far behind. Maybe because I started
A
today
whole
morning.
snapshot, or
Yeah, yeah. I had a old snapshot. That's why. So I have to yeah, restart the server because I cannot catch this many slots. So you can idly catch around like with a good CPU, you can catch like 3,000, 4,000 slots, but you need like a good CPU and a good system to do that. This is too many, so I have to restart once and yeah.
So what's the problem that you did? You took an old snapshot.
Yeah, yeah. So I started today morning to just check everything is working or not. So I
Sure.
had a snapshot from there and loaded up that.
Got it.
So I have to
yeah, it
restart
might be a
and
good opportunity to talk about like a few things, right? What is a snapshot? What does a validator do? Why is this even important? Let's go deeper into whatever you're facing right now, right? Like You mentioned you were using the older snapshot, and it is so, since it's on a older snapshot, it is so far behind that this machine cannot catch up.
Yeah.
Why is that the case? Like, what is it doing that it cannot catch up? Is it like getting individual things from somewhere, or does it have to do some local computation? Is that why you said CPU?
Yeah. So it has to update the state as well, right? So it pulls up the slot, it updates its state. So you have to do again and again while assuming that the current network is proceeding forward. So it's basically you have to, so this node is falling. It's basically just that. So you have a car moving ahead and you have to pace up with that.
Oh,
And you have to
got it.
recompute everything and save to the local
So
state.
with the snapshot, basically what we get is that we get this some kind of cached values that we can, of whatever state is at that point in time,
Yeah.
is pre-verified, and you start from that node snapshot, and so that it makes it easier for you to catch up.
Yeah. Yeah. That's why you don't have to download like from Genesis to till date. You don't have to do that. You already have the middle part covered.
How big is the snapshot on testnet right now?
I believe it's 70 GB or something like that. I might be wrong. It can be the size of mainnet as well, but it's around 70 GB.
How big is mainnet?
Um, mainnet is also, I'm confused between mainnet or testnet size. So yeah, something is 70 GB. I think it's mainnet is 70 GB. Testnet is a bit uh less than that.
Got it. Makes sense. Okay, let's
So
restart the snapshot.
Yeah, I mean, in this, like, you could also talk about like why this. You mentioned, uh, you also mentioned these validators have a note account, right? So why does that exist a note account? Like, what do these validators do?
these validators, so validators in general, the same code base can operate in like two different ways. First is a consensus voting validator, other is like just non-voting RPC node. So
Sorry,
non-voting RPC.
do you mind opening like a
Oh,
whiteboard thingy and explaining over there?
status is so.
Yeah, I think
So
Oh,
editor, we're
we
back second part. इसके बाद first वाला part
it
पूरा
might
रहेगा.
have
Then इसके.
it might have caught up now.
no no
Oh, it's still behind.
still old. Yeah, it's still
It says
well,
your
it's
average is minus 1.4 slots a second. Does that mean
yeah. I'm falling behind.
so? Is that
Yeah,
because of
every
the
second is
Yeah, for some reason.
falling behind. Like,
Yeah,
the machine
did
isn't
you?
fast enough? Is that what it means?
no. I think
No, I
I
think when
have
he
a
restarted,
error.
he didn't change the snapshot. I think when you
No,
did
I
the
moved the
systemctl.
snapshot.
Okay.
Yeah, let me.
One second, I'll just be back. I need to use the washroom.
Mhm. So let me do this.
One thing that would also be good through is
Mhm.
to show how people can get profitable. Like, if you're up for it, maybe you could just show it in a Google sheet. The
We have
cost
the
for the,
Cogent crypto thing. So yeah, let me pull that
yeah,
up.
it would be worth, yeah, that would be worth showing for anyone considering to uh, run. Yeah,
Yeah,
exactly.
we can show this,
Yeah,
and in this maybe like server cost and all, we can do all the math here.
yeah. Yeah, it would also be when you're discussing block rewards, right? Like, it
Hmm.
would be good to talk about the validator burn, like how the inflation works,
Yeah.
how much of the things that get, like, what happens to the transaction fees that are paid.
Hmm.
Maybe if you want to talk about priority fees, feel free to go for it as well, because now you can also talk about GTO, MEV, and all
Yeah.
of that, and close it out like for the next 10-15 minutes.
Yeah. Oh, block reward is zero for some. Yeah. Something wrong with the calculator.
Oh, okay. Oh shit.
Yeah, something is broken because it's saying I'm making like zero money. So
Wait, what's
it's
up?
probably. Oh, we were figuring out we can use this like thing. So this is like a profitability calculator for validators. You can enter your server amount, what are your configuration, how much SOL you have, SOL price, etc., inflation, and it does math for you. So how much yearly you make.
Very cool.
So, but something is broken.
These guys are
The
also from India, right? Cogent Crypto.
no, Cogent Crypto is not from India.
Okay.
But I guess hard-coded values work, so we should be fine.
Okay. Yeah. So I think it would be good to show in the sometime in the podcast, what it costs, how much, like, if how they can be profitable. So would be a good call to action.
All right, where are we at? I think, did we restart? Are we starting it again?
Yeah, I'm restarting it again. Let's see.
So when you restart, it gets the fresh snapshot and then starts from there.
No, so I
Yeah, he
delete
deleted
the
all
snapshot.
the.
Yeah, I deleted the whole directory and
Got it. Oh, okay. If you did not read the directory, then it would have picked the old snapshot.
no, that then also it should match with the on-chain version. Either one of my known
Testnet
validators.
is out.
Yeah, testnet is off, but one of my known validator where I'm pulling the snapshot from has like old snapshot maybe. So all these like maybe we can add in the video, but all the like the testnet validators that I added here, right?
Ah,
Stars. These so you only allowed to pull like snapshot from these and because like you have to trust the validator to pull the snapshot. So that's
right.
why. And these are few Anza guys. I believe this is Anza. And I think this is also Anza. So something is off there where I'm pulling the snapshot from. I'm getting the old snapshot. Let's see
All
one
right.
more try.
What is that? Is that a public key for the known
Yeah,
validator?
that's their identity
Yeah,
key.
Oh, okay. How do you reach from the identity key to their server? Like, how do you start to?
So that is the internal process. But I'm downloading from here. What is
Okay, there you
this
go.
IP? Yeah, I need a 1 sec. Solana validators not able to boost.
he can show the maybe show the CDRS into it.
Yeah, something is off with this guy. 144. Yeah, if I restart back at like I'll remove this. So one of the this validator is breaking for some reason. Like giving me wrong snapshot probably. That's why I'm
Do you
starting
want to
old.
remove that from the?
Yeah.
Remove that. Do you want to remove them from the known?
Mm. But then I might not get any validators. So that will be a problem. This guy.
It's this thing, right?
Yeah.
Uh, you won't have any snapshot.
I can have to do like my servers are behind tails and all, so I cannot randomly add them.
They're behind
Oh,
what?
Tails tail scale. Tail scale and VPN servers there. So
Got it.
uh what I can do is maybe restart it. But this will take time. We don't have anything that is like close to us. So
All right. Is
mm.
there a way for me to track if I have X amount of soul and if I'm spending, some money on my validator, electricity, things like these, how much will I be profitable or not by the end of month?
Yeah, you can use the Cogent crypto validator. So like there's the this thing profitability calculator. You just have to fill up few numbers for this. I guess I can pull up some mine only. So
Oh, okay.
I have like so my server cost is some $12,000. That is a lot because I have like few machines and my commission is zero, MEV is 10%. My current stake is 83,000 sold. It has like all the price pulled up, and as I told earlier, it's like two soul roughly you need per epoch to vote, so it considers voting cost, etc. And the block reward is not updated, but roughly the block reward is 0.05, and roughly I make 112 20K roughly year on year, depending on the soul price and rewards, etc., etc., to keep consistent. But yeah, so anyone can like do the math. But getting this stake is not that easy. It took me like 8 months to get here, 9 months actually. And but as an individual, it's super hard to pull stake. And initially, you have to just give people rewards more than what like the base APY is. So the base APY right now is around 9.9 to 10%, somewhere in between. But you have to give money from your own profits to get attract stake, and there's a bunch of other stuff you have to do. But yeah,
Got it.
Interesting. So essentially, what you're saying is that if you are able to, you can, th- like, if you have the skills, DevOps skills to run a very high availability server, you can attract stake, you can actually make like a net profit of like 120K, which is like a engineer's salary.
yeah, yeah,
Or a few engineers.
and yeah, and and this is like my node is not even like considered heavy stake. So to get heavy stake, you have to be at 150 to 100, yeah, 180K soul range and more. So around 180K, I'm missing some 100K. So I'm one of the small guys in that sense.
Got it. One question: your commission is zero, you said.
Yeah.
So how are you making money if it's not
So
your soul and everyone?
So commission is the so you have three types of specific rewards. First is the block reward that you get by being leader. Second is the thing that you get for voting. That is inflation reward or something like that. And third is the MEV cost. Since I'm running Gito client, so I have a 10% commission. So whatever, like let's say like my node produces 10 soul in a epoch, then I get like zero point 0.1 of that. And same is commission. So that is for voting. I have zero to because like validators are super competitive. So you have to keep things zero or you don't take any commission there. Plus I have like block rewards. So the block rewards majorly are the main source of the funds.
So block rewards are not gone. Don't go to people who stake. They remain with the
Yeah,
validator.
by default it doesn't, but you can send them to the people. So specific investors and all, you can do specific APY deals. So you give them extra APY. That is basically you're sending the block reward to them back. That you
Got it.
usually don't, no one sends it. So that's why like you get like few LSTs, or if someone know like liquid staking tokens, those guys have like few have like lower APYs, few have like a bit higher APY. That's because of this. You can play around with like how much you're returning to the people, and yeah.
Brings me to a follow-up question. How do you make an LSP if you already have like a validator? How
Well,
hard is that?
you can use Santam. So Santam is one of the bigger protocols on Solana. Mhm.
Hmm.
Santam has their full guide on making a LST and all. So
Hmm.
you can use that. It's not a like a UI form. You have to use CLI to mint a token, and then you have to contact their team to get you like listed in their list and all. But yeah, majorly you can use Santam. They have like in their learn docs, I believe they have a guide for this somewhere. Setting up a LST token mint. So you can follow just this guide. But again, don't spam Santam guys. And yeah, but you have to like get whitelisted by them. So you can like create a LST, but it won't be show up in their router and all. So these guys have their own router and like whole pool stuff. So the let's say aerosol. So the APY basically is like mapped one to one. So they have a pool of soul and they mint soul. So based on that reserve ratio, if someone knows that, and reserve ratio based pay, they calculate the APY.
Got it. Makes sense. Is this what you use for Ice Soul as
Yeah,
well?
yeah, yeah. ISOL is also here. Yeah. When we minted, we use Santa.
What other practices do you use? You mentioned you have more than one nodes. If one fails, the other becomes, the primary node. What else do you do to
Yeah.
make sure your node is up if you're taking a flight?
Well, so there's like three backup nodes for me. So one fail. So there's like failover mechanism. And if three fails, then I don't have anything as backup. But yeah, that's and someone else also have a backup access. So in case I'm on a flight or something like that, then that guy can help around. So he's a good friend, so that's why he has access.
Got it. Makes sense. And I'm assuming these are on different cloud providers, so that if one cloud is
Yeah,
down,
and it's not even on like so all of them are like proper data centers with like bare metal nodes and I don't have like two same provider giving me two nodes, so
Mhm.
that is plus cities are different, so I don't even have like same city like two nodes. Every node is in a different city as well.
That's all the questions I have. Shake.
Yeah, I think this is good. I think we covered like the basics of why the validator. Maybe we could do a part two about stake SQO as like the other reasons why stake is important, but that's not really related to validator, right? We could probably do that as a part two or later, but I think for this discussion it's very quite in depth and we have covered the entire breadth.
All right. One thing I would love to do, if you have time later, through, is maybe start a non-voting node on a machine of my own and see. I'm assuming for that I don't need any stake. I just need hardware, and that's it, I
Yeah,
guess.
yeah.
So would be nice to see how can you start your own RPC on one of these clouds. Um, so if you're free right now, we can do that right now, or we can do it later as well. But that would be a good ending to the video, I think.
We'll need like a bigger machine. I can show you my RPC node if that works, and the snapshot then
Yeah, that's
yeah. I'll show you my RPC node. So I also have a like a dedicated RPC node for myself.
what do you
Uh,
use it for?
Yeah,
well,
that
I
was my
cannot tell
question
too
too.
much,
Why do
but
you need a? Okay, sure.
yeah,
Oh, okay.
I do few things.
Pump sniper.
Not a pound sniper, but it's a very big node. It has like 1.1 TB of RAM, and yeah, it's a big node. So it has like all the stuff running. So I got uh, I'll show a few things.
For most people listening to this video, 1.1 TB RAM. It's Dhruv
It's
said
too.
1.1 TB RAM, not the hard disk.
Yeah, that's. So
How
I
much
don't
does that
know.
cost?
This machine is like some $2,000 monthly.
That's pretty good, no?
Well, it's super hard to find a good CPU a provider and with a good. So this is in Amsterdam. So I'm
Okay.
at like very prime location, center of the
Mm.
yeah. So and yeah, I have like Yellowstone gRPC setup. So this is Geyser. If someone knows, so Geyser allows you to pull data out of like the blockchain, and it's a streaming service thing. So Triton built like Yellowstone gRPC with gRPC based Geyser config that allows you to pull data. So I use that. Then some basic stuff, same stuff that I showed earlier. I have a startup script. Uh, just few differences here that I have like a non-voting flag. I have full RPC API marked. So these two are there, and I have like transaction history enabled. So validators they cut logs and all. So for that, I have like history enabled so I can search stuff. The geyser config that I showed.
Mm.
Uh, we have account indexes, so you can keep these indexes in memory. So that allows you to faster retrieve the data. That is basically caching of the data that's in the like in my disk. And yeah, majorly just that is the difference specifically. You just need a bigger machine.
Got it. And the geyser config, what
Mhm.
does that contain? Does it contain the addresses you're interested in, things like these?
No, no. So this is the default config. So yeah, so it's a the default config that whatever size I want to do. So I want to keep my channel capacity, etc. So if someone is subscribing to the using any filters, so I have limits on filters. So I can do like 100,000. What's this? Yeah, 100,000 accounts max at a time. So how much you can subscribe, what size you can subscribe, And so there was few other stuff around like TLS configs, like at what port I'm running the whole thing. Yeah,
Where do you
basically
specify?
just. Mhm.
Got it. Where do you specify the addresses you're interested in?
That is outside, so it's a client-side code you subscribe by.
Oh, okay. So Geyser plugin runs here, and you have some client that connects to the
Yeah,
client. And
yeah,
okay, okay, okay. Super interesting. All right. And then in that client, you write the code to dump data to Postgres or wherever you want to send it.
yeah. So it doesn't get like dumped to Postgres in my case. It keeps in memory and whatever I do, I do. So yeah,
Yeah, so Yellowstone specifically, that's like it opens a gRPC stream
Hmm.
for all the thing that you want. So you could connect another node to the end of the stream and then you can process it.
Got it. So what do you use this for?
He can't tell us.
uh, as such, I have like bunch of Grafana dashboard, few stuff I was building, like watcher bots, not for like that for the Grafana and all. So the one thing I want to like, it's on my list to wrap up, but basically I'm using tail here, right, to do logs. So I have like a thing, script that does like dump my this tail log to Datadog. So if someone has used
Mhm.
Datadog, I can like view real-time logs on anywhere, and few stuff I have like ongoing projects that I cannot wrap up because of the stuff. But yeah,
Got it. Super interesting. Is this where you spend most of your time on validator infra?
yeah, these days I'm just chilling and doing this, nothing else.
Pretty much it. Super exciting stuff, man. Thanks for sharing it with us, and also thanks for running an indie validator.
Yeah,
It's like most validators typically are run by like institutions or large corp. It's very interesting to see independent folks running a validator.
Cool. I think with that we'll wrap it, guys. Thank you so much for joining. I would try and create a non-voting RPC node myself, maybe towards the end of the video, so we can go through all the steps one by one. How do you get a new machine, bare metal? How do you SSH into it? How do you run the scripts? What are the scripts? So you have a step-by-step guide for running a non-voting node as well. If you want to run a voting node, make sure you have the stake figured out, and only after that does it make sense for you to do this. With that, thank you so much, Dhruv, for coming, and we hope to have you again on another
yeah,
conversation in the future.
yeah.